Hello IBSL2, welcome to 2.6, tangents and normals. So we have already talked about how the tangent is a line that basically hits your function at one point and then continues. It doesn't hit any other points in that surrounding area. And we're going to learn what a normal is today, and then we're also going to find out how to write the equations of a tangent line and a normal line. So if you just consider a function, all right, and you can draw any kind of function that you would like. Let's try to make that one a little bit better. Okay, so I'm going to go ahead and draw any function that I would like. So I'm going to draw a polynomial. And I'm going to say, all right, if I have a function that has a tangent at this point, what's going to happen is that's my tangent line. My normal line is going to be perpendicular to my tangent line, and I will use the green to represent the perpendicular. Okay, so as long as we have a right angle, there we go, in between your tangent line, so I'm going to label this one as my tangent. We've been doing a lot with tangent lines, so we know that a tangent, the slope of the tangent is my derivative, and over here is my normal line. All right, and then this is the normal. So a normal and a tangent are exactly 90 degrees of each other. They are perpendicular to each other. So if you think back to Algebra 1, remember our slope is rise over run? When you guys had to find the equation of a perpendicular line, you did what with the slope, right? We basically took the opposite reciprocal slope. So that's exactly what we're going to do with our normal. So make sure you guys have a formal definition written down, right? A normal is just a line that's perpendicular to the tangent at a particular point, whatever the x value is, on a function f of x, whatever your function is, okay? Therefore, the slope of a normal. So if I'm going to write down what my slope is, I'm going to take the opposite and reciprocal of whatever my original slope is. And remember, this is back to Algebra 1. Anytime you drew a perpendicular line, you took the opposite and reciprocal slope. And that would make the line go in the opposite direction. So if one line was positive slope, the other is negative slope. If one was up 2 over 5, now your perpendicular line is up 5 over 2, right? So opposite and reciprocal. Reciprocal. Okay, so now that we have this idea of what the normal actually is, let's think back a little bit more to Algebra 1 and consider these 3 points here. The equation of a line. Okay, we can either use y equals mx plus b. Let's try that again. I'm going to go ahead and pull out. There we go. So we can either use y equals mx plus b here, or we can also use y minus y sub 1 is equal to the slope times x minus x sub 1. Okay, and in this case, all right, m is our slope. M is always our slope. So I'm going to just highlight that over here. M equals the slope. And our y1 and our x1, so if you did want to use the point slope form, x1 and y1, oh my goodness, there we go, is a point. Whatever the point is, let's try that one more time. Okay, there we go. Oh, almost. All right, x1 and y1 is a point on your line. So whichever form that you would prefer to use, sometimes one will be easier than the other. But remember, this is your slope-intercept form. And this one over here is your point slope form. Again, this is just a little revert back to Algebra 1 here to bring this all back and fresh in our heads. Equation of a horizontal line. A horizontal line will cross the y-axis. So it's always going to be y equals, and then that's wherever your y-intercept is. So remember, your b is your y-intercept. So it's y equals wherever your y-intercept happens to be. A vertical line crosses the x-axis, and it is, wherever the x-intercept is. Sometimes a is used as x-intercept, but really you're just saying x is equal to whatever point that you cross the x-axis at. So this is a little bit of Algebra 1 review, just so that we know what we're talking about when we get into the problems here. So how do we bring this up to calculus level? Find the equation of the tangent. If I'm being asked to find the equation of the tangent line, well, to find any equation, I'm going to underline that word, any linear equation, and we know the tangent is a line, we need to find the slope, and then we also need a point, whether it is the y-intercept, if I'm doing slope-intercept form, or whether it's just another point on the line if I want to use the point-slope form. That is your choice. So we are going to, point-slope form tends to be a little bit easier for this, so that's how we're going to start. So 3 easy steps. Number 1, find the slope. In order to find the slope of a tangent line is the derivative. So we are going to find f prime. Okay? You are given the original function, and we're trying to find the tangent line somewhere on this graph. In particular, for this problem, where x is equal to 1. So f prime is equal to, well, we're going to use the power rule, so 2x. But we're actually asked to find the slope at x equals 1. So we're asked to find the slope at a particular point. So I'm actually going to find f prime at 1. That means that my slope is now 2 times 1. So I actually have a value for my slope when x equals 1, which is 2. My second step, once I have the slope, let's find a point that's on my line. If I have a point that's on my line, well, the point that I want to find my tangent at is x equals 1. So if I already know that x is equal to 1, how do I find a y value? I go back to my original, and I substitute 1 in for x. Remember, I'm going back to the original because I want to find an actual point on my line. So I'm going to do 1 squared plus 1. Well, look at that. We get a y value of 2. So now my point is 1, 2. Step 3, actually write the equation. And I'm going to use the point-slope form of a linear equation because it's easy because I have a slope and I have a point. So I'm going to say that y minus my y value, which is 2, is equal to my slope, which is 2, multiplied by x minus my x value, which is 1. And that is actually my equation of a line. Of course, I can make it look a little bit nicer. I can move the 2 over, so now I've got my 2x as my slope. If I distribute this 2, I get negative 2, and then I add this 2 over, well, then I get 0. So my equation is actually just y equals 2x. Beautiful. That's my equation of my tangent line. What does this actually look like? I'm going to do a little brain bubble here to the side in case you guys are curious to see what you should be thinking about in your head, right? Well, x squared plus 1. Okay, so here's my xy axis. X squared plus 1 is approximately here. Okay, if that's x squared plus 1, here is x equals 1. So now I have a tangent line at x equals 1. All right. Oh, not perfect. Let me grab this, see if I can move it a little bit. See if I can make it a little bit more tangent. Okay. All right. So what this is basically saying, almost right there. What this is basically saying is that my my tangent equation has an has a y-intercept of 0 because I don't have a plus b here. Well, it does. It crosses through 0, and I should have a slope of 2. Well, my picture was a little quick sketch. My slope should be 2, so it should be technically a little bit steeper than this. But that's really what I just found, was my equation of the tangent line right there. Perfect. So now let's see how this works for a normal line. Find the equation of a normal. So I'm going to switch this up just a bit. If I'm finding the equation of a normal, remember this line is now the perpendicular to my tangent. So I'm going to find the same information. Step 1, I'm still going to find the slope. All right, so if I'm finding the slope, remember I can rewrite this. My function, before I even find the slope, I'm going to rewrite this function here because this is bugging me that I have a denominator. We could use the quotient rule here, but we don't have to. So 8, and this is going to be x to the negative 1/2. If I bring up the square root of x, and I write my square root as a fraction exponent, a rational exponent. So now I have negative 1/2. 8 times x to the negative 1/2. Now when I find my derivative, I'm going to go ahead and take negative 1/2 times 8. That will make it negative 4. And I now have x to the negative 3/2 if I subtract 1 from the exponent. I really want to find my slope when x equals 4. So I'm going to go ahead and put 4 in. I'm also going to rewrite this so that it makes a little bit more sense here. I'm going to rewrite it as a radical. So I have negative 4 divided by. And here's where I've got a square root to the 3rd power, and the negative means it's in the denominator. So I have a square root of x, which is really 4, to the 3rd power, and it's in the denominator. Square root of 4 is 2. 2 cubed is 8. So now I have negative 4 over 8, which is really negative 1/2. However, because this is the equation of my normal, I do not want to keep negative 1/2. I want to take the opposite and reciprocal. So now I'm going to write my slope is actually going to be positive 2. Step 2, I'm going to go ahead and find my point. If I have an x value of 4, we talked about this already. If I take 4 and substitute it into the original, well, square root of 4 is 2, so now I really have 8 divided by 2, which is 4. So I now have a point. My 3rd step is to actually write my equation. And again, I'm going to use point slope form because I think that is the easiest one to work with here since I have a point and a slope. So y minus the y value. So I have y minus 4, excuse me, equal 4. Said minus, wrote equals. Let's try that one more time. I'm just giving you guys time so that you guys can try this. So I'm not doing it for you. So y minus 4 is equal to, my slope is 2. And now I have my x minus 4. All right. Let me see if I can neaten this up a bit. I can distribute my 2, so I have 2x. 2 times negative 4 is negative 8, and if I add this 4 over, I'm going to get positive 4. So y is equal to 2x plus 4. And again, this is the slope of this is the equation of the normal line. The normal line. So if you graph 8 over square root of x, this line, y equals 2x plus 4, should look like a perpendicular line to your tangent. Great. This is the basic setup, and these are the 2 equations that we really want you guys to learn from our video today. However, of course, there are many, many different things that you guys can do with a tangent line and a normal line, and there are different ways of asking these questions. So we might not always ask, write the equation of a tangent line, right? What if the tangent happens to be horizontal or vertical? Then what would the slope be? Or what if the normal was vertical or horizontal? Then how would you figure out the tangent from the normal? So you can be thinking about all these different things just by knowing what a tangent and a normal line really are and where they are in your picture. So really be thinking when you're going through these problems, what does the picture look like? What does the function look like? And what am I really finding here? On video part 2, we're going to go into 3 other examples that could possibly be extensions of how to find a tangent and a normal and what you can do with them. So stay tuned.